All right, today we're going to talk about the Earth as a system. And this system is comprised of five main spheres. So those spheres that we see, some of them sound familiar possibly, and some of them sound very different. So we're going to look at those different spheres today that make up the Earth system. All right, the first one is the Geosphere. And you might notice that geo sounds kind of familiar, so this word isn't super foreign to your ears. And this one's going to include mostly solid rock and things on the surface, but all the minerals and things of the planet. We have the atmosphere, and that is going to be, now when it's described as a thin layer, obviously it's not thin compared to a layer of like a t-shirt, but it's thin compared to the entire planet, and that's going to be all the gases that surround the Earth. All right, the hydrosphere. This is going to include all of the water on the planet. We're going to be looking primarily at liquid water as a hydrosphere. Here, the way we're breaking these into five spheres. So the hydrosphere is going to be all the liquid water, whether on the surface or below the surface, like in aquifers. All right, so the cryosphere. This is why I said we're going to refer to the hydrosphere as like the liquid sphere, because the cryosphere is going to be all of the solid water on the planet. So things like glaciers and ice sheets and even snow and hail. All right, and then the biosphere is going to be the final one that wraps it up. And this is where us as humans studying this, the biosphere is all the living things. So when we understand what's going on with all of these, we are benefiting our own sphere by being able to better survive and better use these other spheres to keep things going right. All right, so we're going to talk about each one of these spheres. Just briefly, we're not going to really discuss how they interact as much today, more just what are the different spheres. So you'll see the geosphere. So in this picture alone, we have several different things. We have the sand here. We have underneath all of the vegetation, you would see rocks and mountain and things like that. All of that, and even though the sand that goes underneath, that's below the water, all of that is going to be the geosphere. It includes all the soil, rocks, and minerals on the Earth. So like I said, even something tiny like this grain of sand down here, or something huge like this entire mountain of whatever potentially type of rock it is going to be part of the geosphere. All right, now the atmosphere. The atmosphere is kind of hard to see in pictures, obviously, because it's an invisible layer. So typically we're looking for things like its evidence. So the fact that these trees are being pushed by something that you can't see, and we could, if we were there, we would know that's the wind. So the atmosphere not only is the wind and the moving air, but it is literally just the air that most living things need, the way it's composed, to keep us alive. So it's made up mainly of nitrogen. There also is a good amount of oxygen, and then really just a small amount of other trace gases. Now, I want to talk about this phrase that you'll see in the textbook. You'll hear it said trace gases, or a small amount. We're talking about a relationship here as far as when they say small, because it's a small amount of this entire huge Earth system. So if the Earth system has a really large amount of gas, the small trace amount really is still a good amount. It's just not anything compared to all of the other gases that we have. So when we say trace amount, it's trace compared to the other amounts, but it's still actually a pretty large amount of overall gases, things like carbon dioxide and water vapor. I think most of you would say when you see in the sky and you feel humidity, even a trace amount of something when it's composed of a gigantic amount can still be noticeable. So these trace gases really are something that's important to focus on when we look at the atmosphere. All right, hydrosphere. So as I said earlier, this is as far as our Florida standard we're looking at here. We're going to be looking at the hydrosphere mainly as the liquid water on the planet or under the surface. Especially here in Florida, we have lots of groundwater. So things like rivers, oceans, but even clouds and fog are going to be liquid water. So just because it's in the air doesn't mean that clouds, they're still droplets of water, so they're liquid. Fog is just a low version of a cloud. So even those are still part of it. Hydrosphere includes all liquid water. All right, now cryosphere. This is going to be the one where, even though technically this is water, and it could fall under the hydrosphere, we're going to put it into its own category called the cryosphere because it's solid. And it does have a pretty profound effect on all of the Earth system. So when you're looking at, even though it makes up a small amount overall of mass and everything compared to the other things, when it goes through changes, it influences the others quite a bit. So the cryosphere is going to be things like glaciers, ice sheets, but it can be things as well as snow and hail too. Snow covers vast amounts of area, and hail does have a pretty strong interaction with things like the biosphere. And the biosphere, finally the one we're talking about at the end, which is going to include us and every single living thing that there is. So when we talked about cell theory, that we referred to things that were living as either being prokaryotes or eukaryotes. Both of those fall into the biosphere. So whether you are a single cell with no nucleus and you're living somewhere, you are part of the biosphere. Or if you are a multi-celled eukaryote with complex cells that have a nucleus, then you still would be in the biosphere, because this is all the living things. And as far as we define life, as long as it's one or more cell, then you fit into this group. But it's also an interesting group because it includes the habitats. So really, when you talk about living things, they're kind of almost everywhere around the planet. So there's really no boundary of the biosphere. You can't just be like, well, you could say that as the glacier is melting, it's turning from cryo into the hydrosphere. There's a very clear boundary of it melted, now it's this new sphere. But this one, not quite so much, because of the fact that they are themselves a living thing. So this owl, this bison, this wolf, they are part of the biosphere, but their homes also are as well. So even things like single cell bacteria fall into this category. So a quick summary, we have our 5 spheres that make up the Earth system: the geo, atmo, hydro, cryo, and biosphere. All of those each have kind of their own identity, but together they make up the Earth system. All of these systems influence each other. Sometimes those influences benefit the biosphere, sometimes they don't. And most of the influences that we look at are looking at through the lens of a biosphere. How is it affecting living things and their environments? A change in one system typically is going to cause a change in one or more. And matter and energy. So whether it is literally water evaporating from the ocean and going into the atmosphere, or it's energy as wind moving around, the spheres interact. That's kind of one of the big things. So today our goal was, what are the spheres? What is each one of their own little individual identity? And then you're going to see in the following up lesson, we're going to be looking at how they interact with each other, how they kind of influence each other. So remember that our Earth spheres are a series of different groups of things on our planet that work together. So that word sphere, don't get too hung up on that being like, oh, each one of these is a circular object, because that's not really what we're using. It's not really a geometric type of sphere.